Hello, my name is David and welcome to the screencast. What we're going to talk about today is making a persistent ignorant application architecture. And what that means is that we'll have a set of high-level objects for our data context as well as our entities, and then we'll have a low-level layer that actually talks to entity framework, which we'll use as our ORM. The advantage of this is the majority of our application architecture will never even know that we're using entity framework, and only a small portion will. And that allows us to maintain data library very easily, as well as make changes to the ORM with very little maintenance. So to get started, we're going to go ahead and create two projects. The first project will be a console app, and we'll call this Northwind. And this will be where we actually demonstrate the work that we'll do in this demo. And then we'll create another, this will be a class library, DLL file, and we'll call this northwind.data. And there's three main components of this data library that we need to actually take care of. We're going to have an advanced namespace called data contracts, and this will store our interfaces that describe our entities. And then we'll have another folder called entity, which will actually store the entity data models, as well as our entity specific data context, which will derive from object context. And then what we'll do in the root of the namespace, our most common used objects, the actual entities themselves, as well as our high level data context will live in the root namespace of our data library. So to start off all of this work, we're going to create our first data contract, and this will represent an employee, and this will be an interface. And we're going to only describe a few properties in here. We're going to have a name property. Actually, we'll do first and last names. And then we'll have an email property. And then what we're going to do is create another data contract real quick. And we'll call this iEntity. And this is simply going to provide a ID property. Now what we'll do is we'll take our iEmployee and we'll do iEntity. So we'll say anything that implements our employee interface will also need to implement the iEntity interface as well. Because remember, interfaces technically don't derive from other interfaces. Okay, now those are our advanced contracts that describe our entity. Now we actually want to make the actual implementation of that. So we're going to create an actual class called employee. Which will implement the interface we just created. And we're going to make most of these automatic properties. And we'll move our, okay, there we go. We'll just leave it as is. And we're going to provide a couple default constructors. The first constructor will just be blank. And then we'll delegate it down to another constructor. I'll actually delegate that down to the second constructor, which will be first name, string last name. We won't create one that only has just first name or just last name. We want those to be set as a pair or not at all. We'll delegate that down to the most complicated constructor that we'll make. And then our last constructor will be the full constructor for first name, last name, as well as email. And then in this constructor, we'll actually set the properties of those values. Okay. So here you can see the chain of events. We have our first constructor delegating to the second constructor, which delegates to the final constructor that does all the work. So very easy for our implementation. Okay, we're not going to worry about any business logic or anything like that for this demo. So now we can move on to actually start creating the data contexts. So the first step to creating our data context is we're actually going to start with the low-level context, the entity one. So we're going to create a new class. I'll call this entity data context. Now there's a couple things we're going to do with this, and the first one is we're going to close out the constructor to the outside world. And the reason we're doing this is we're actually going to instead expose the factory pattern to create this. So we're going to derive from object context. I think we might be missing a reference here. Yep, okay. And what we're going to do is delegate our private constructor to the object context constructor. And now we need to actually declare our navigation properties and our object sets and things like that. So the first one, we're just going to have a object set of type employee. Now, for those of you who have used Entity Framework, we're taking the code first approach to this, which is why we're creating the data context ourselves instead of in the entity model. And I'll show you how to take care of all the rest as we progress through this. So we're going to have a employees object set. And all this is going to do is return. And in our constructor, we're going to instantiate that. All right. And then the next thing we're going to do is expose our factory pattern. And we're going to create this from a connection string. Now there's a couple ways that you can do this. In one of our existing applications, let me grab a code snippet here and show you how we supported multiple databases in our existing applications. Let's actually get rid of that. So this is a code snippet from VaultTrack actually, and all I did was we had a DB connection info structure, and it specifies some properties like what type of database are we working with. So you can see down here we have a supported database enum for MySQL and SQL Server, and we had a database type property in the connection info. So that's one way you can handle switching between different database types in Entity Framework using a factory pattern. And then down here we just return a new entity data context. And we're actually pretty much going to write this same exact method, but we're going to trim it down a bit because in this demo we're not supporting multiple database types. We're just going to be working with only SQL servers. So we can actually remove this entire switch statement and this DB connection info and replace it instead with a provider. Actually, let's call it a SQL MSQL connection string. And then what we'll do is we'll take all of this and just remove it. And actually, we can remove this completely. And then we can specify a connection string here once we actually get to creating our database. Okay. So all this is doing is creating our entity data context manually through entity connection string builder, and then returning a new instance of that. And we're pretty much actually done with our entity data context. So we can move on to creating our high level context. So we're going to create a new class, and we'll call this just data context. Now, there's a couple ways you can do this. This is the key important part of making your application architecture persistence ignorant. So to do that, you can do one of three things. You can derive from entity data context and then provide enumerable properties that return the base class properties, so like the employees object set. You can use generics to support multiple types of underlying data contexts, or you can wrap it, which is what we're going to do. So we're actually going to, we'll let the CLR inject a constructor for us. So we'll have a default parameterless constructor, but we're also going to have a private field for our entity data context. And then what we're going to do is we're going to expose a enumerable of employee. So notice that we're not specifying an object set, so we're not tying this property down to the entity framework. And we're going to call this employees. And then what we'll do is we'll say return context.employees. And then what we'll do is in our data context constructor, we're actually going to go ahead and provide a default constructor. Actually, we'll do, and we're just going to use this to initialize the context, and we'll say entity data context dot create. So here you can see we're using our factory pattern, and I'm just going to call this data context for consistency. All right, and then we can also, we need to declare a save changes method, and we can again delegate that down to the data context. And actually, instead of exposing that property as a enumerable, we're going to expose it as a queryable instead. Okay. And we can provide different types of, we could do business logic in here if we want. And then for actually adding and removing employees, that's another important part, is we're actually going to provide those through the means of methods. So we're going to say add employee. And then we'll delegate that to the data context object. There we go. Okay, and we're going to do the same thing for delete. So we'll do public void delete employee. Actually, we'll do delete object will be better. And then we'll have a system.object entity. And we'll say data context delete object. And then we'll just delegate our call down to there. Okay, so we have the basic functionality for adding and deleting an employee, as well as saving changes to the data context. So the only thing we're really doing is delegating the work down to the entity context. But the way this works is we're not exposing anything entity specific in this class, which will be used in the rest of the application architecture. So the rest of the application will have no idea that we're even using entity framework. And that's the whole point of persistence ignorance. All right, so now that we're done with that, we're actually going to do one more thing and implement the disposable pattern on this. And the reason we're going to do that is because we're holding on to a managed resource, our entity data context, which derives from object context. That's a managed resource that we need to get rid of when the time is available. So here I have a code snippet. We just declare a disposed property. You don't have to do that, I do. And then we're going to make sure we get rid of our data context when we call a dispose method. And then what we're going to do in our employees properties, we'll say if disposed throw new system. And then what we'll do is we'll inline this by extracting the method. And then we can just do that in our property. And that allows the compiler to inline the static function, which provides us better performance. And we can, of course, do the same thing in our save changes method. Pretty much any method, we can put that code in there. And all that allows us to do is, if we dispose the context and we accidentally call a method, we'll get an object dispose exception. All right. So that's all we have to do with our data context. So if we were to go to our program, we could actually start using that data context. And we, of course, need to add a reference to our data library. And we could say something like using, and then we could do something like employee me equals db employees first. For example, we could add employees, so we could say, or we could even change them. We could say me first name. And then we could actually save the changes. So you can see that it works just like an entity data context, except the application actually has no idea that we're even using entity framework. There's no references to entity framework in the rest of our application. It's only in the single data library. And that's exactly what you want in the entire purpose of persistence ignorance. So now we actually need to hook this up. We need to go ahead and create our data model to define the metadata and the schema. So we're just going to call this Northwind. We'll have an empty model. And we'll go ahead and say we have an employee entity with an employees object set with an ID property. Click OK. And we need to add our first name, last name, and email properties. Okay. And the last thing we need to do for persistence ignorance, because out of the box, this data model is generating types. So it's generating another employee object that derives from entity object. We don't want that. So what we want to do is actually go to the properties of our edmx file and remove the entity model code generator that generates these types from the custom tool. And you'll notice that it actually removes the designer file, which is exactly what we want. So we're basically telling entity framework we're going to provide our own types. And actually one thing we want to do so entity framework can create the proper proxies. So we're going to go to our data context and make our entity data context, I believe. There we go. We want to go to our entity data context and then the constructor, set some connection options, make some of these virtual. So we're going to go to our employee class now and make these properties virtual. Which will allow entity framework to create a proxy of our class, which will not only increase performance, but allow entity framework to do a lot of other magic under the hood. There's an MSDN article on that if you want to learn how all that works. And then it also allows us to support lazy loading, deferred loading. Okay. So let's go back to our model. We have that done. We can actually go ahead and create a database at this point. So we're going to say generate database from model, and I'm going to provide a new connection to a SQL server. I'm going to say when TFS, and we'll go ahead and do I'll call this Northwind. And what we're doing is creating the database, and we're going to save our connection string in the app config. And we'll hope everything went well. And then what we'll do is we'll actually open our database up, and I'll create a default piece of data so you can see that this works. And we are missing our employees tables. So let's go back to our EDMX file. Oops, we want to for some reason it's not, we'll create the table manually. So say we have an ID column. This is an integer. We have a first name. So this is in varchar 50, for example. Okay. Set that as our primary key, and we need it to auto increment. And that is one thing we forgot to do in the model. So we need to go back to Visual Studio real quick. And okay, it is already actually our primary key. So we're going to create a default row data in here. And we'll go to our program. We're going to go to our data context, and the last thing we need to do real quick is set our connection string. So we are going to grab that from the provider connection string. I remember earlier in the presentation I said we need to provide that here. That's what we're going to do. Okay. So now we should be able to run this. And we're having a problem finding our metadata, and that's because I actually copied this code snippet. So we need to actually say is northwind.csdl. There we go. Okay, now one thing to note, because we're using code first, is see that we have this entity.dynamicproxies.employee. That's what I was talking about in terms of entity framework creating a proxy, but now we can see that we have our data, email, first name, ID, and last name, and it's all populated. And that's actually working, connecting to the database. So that's pretty much it. As you can see, the whole advantage of that is we have one little portion of our data library that knows everything about entity framework, and everywhere else does not. So the rest of our program has no idea that we're using Entity Framework. We don't have to specify any type of connection string to actually create the context, which means maintenance. It's very easy. So we can handle all of that in our high-level data context that we created here. And it's just a very flexible pattern that you can use in your applications to improve your application architecture. So I will provide the source code in the comments. I'll provide a link to that. I'll put it up on my blog. If you have any questions, post them in the comments below. And thank you for watching.